All right, so today we're going to be talking about Chapter 8, Lesson 2. This is talking about the volume of a cone. Now, if you recall from when we did last year in 7th grade, the volume of a pyramid, that formula was 1/3 times the area of the base and then multiplied by the height. Now, if we look at this pyramid here, the base of this pyramid happens to be, now it doesn't necessarily look like a rectangle, but it is still a quadrilateral. And the area of a quadrilateral, in this case, would be the length times the width. So if we look back at this formula then, for a pyramid, we'd have 1/3. Length times width would be the area of the base, and then the height of the pyramid. Now, the nice thing is, when we start looking at cones, the formula is exactly the same. 1/3 times the area of the base times the height. Now, the only difference is, for a cone, the area of the base is always going to be dealing with a circle. So, if we look at this then, the base is a circle. So the area formula for a circle is pi r squared. So if we take this circle and erase it now, we see we have this line right here. That line is the radius. The radius is always from the edge of the circle to the center. And pi, last year, if you recall, we used two different numbers. We used 3.14, or we used pi as about 22/7. Both of those are perfectly great to use. You can always just use the pi button on your calculator as well, that I will show you in a moment. But regardless, when we start looking back at our formula here, volume 1/3, the area of the base in this case, which is a circle, is pi r squared. Now, the thing to keep in mind, it's only the r that's being squared, it's not the pi. And then we multiply that by the height of the cone. So let's go through a couple of examples here. Example 1 here, it says find the volume of the cone and then round to the nearest tenth. So we're going to be looking at volume of 1/3 pi r squared h, where the two variables that we don't know would be r, which is the radius again, and h, which is the height. So let's look over here. The height of this cone is going to be this one right here, from the tip of the cone down to the base. And it says that that's going to be 4 inches. Except we want that on the height. The other one we're looking for is the radius. Now, the only problem is we have the dimension that goes all the way across. And we don't want that, because this dimension is the diameter. Now, if you recall from last year as well, when we're looking for the radius is 1/2 the diameter. So if the diameter is 5 inches, that means the radius would be 2.5 inches. We're going to come up here and use 2.5 inches. Now I have all the information that I need to help me solve this problem. So, formula here, I have 1/3 pi r was 2.5 inches. That's from right here. And the height would then be 4 inches. Now, I could use 3.14 here, but regardless, we're going to probably want to use a calculator. So let's open up our calculator app here. So we have a couple buttons that we need to make sure that we are aware of. The first button is down here. This here is the fraction button. So if I type the fraction button in, it now gives me a dividing bar, where I can put 1 in the numerator and 3 in the denominator. Another button that we want to keep in mind is this one right here, this pi symbol. That's going to be our pi. And then we're going to want to put in 2.5. This button right here, or this one right here, can help us get up to a square. So if we click on this button, the exponent just increases by 1 each time. So right now it is 1, so if I type it in or tap it, we get 2. And then multiply by 4. If I hit enter here, I get 26.1799. And so on and so forth. But it does say to round to the nearest tenth, which means if I'm rounding to the nearest tenth, which is the 1 is in that place, I'm going to be looking at the next place value to the right. So in this case, that place value would be the hundredths place, and the number in that place would be a 7. So if you recall from probably elementary school, if it's 5 or more, we're going to bring this number up 1, and if it's 4 or less, we're going to let that number stay. So 7 is more than 5, so our volume is about equal to 26.2. And because volume is dealing with 3-dimensional shapes, we're going to be having our units be cubed, and our units are inches. All right, let's look at our next example then. It says a cone-shaped vase has a height of 15 centimeters and a diameter of 8 centimeters. What is the volume of the vase? Round to the nearest tenth. Again, we can use our formula here. Volume is equal to 1/3 pi r squared h. We need to know what r is. We need to know what h is. It says the vase has a height of 15 centimeters. So we're going to say 15 centimeters is the height. It says a diameter of 8 centimeters. We want the radius. So the radius is going to be half of that. So half of 8 would be 4 centimeters. And again, I can use the formula here. So 1/3 pi r is 4 centimeters, and the height is 15 centimeters. So again, on my calculator, 1/3 times pi times 4 squared times 15. And that gets me 251.327 and so on. So our volume, we are rounding to the nearest tenth again. Make sure that we keep that in mind. So the tenths place is the first place value after the decimal point, which means we're going to be looking at the second place value to determine what we round it to. So this number is 2, which is 4 or less, so we're going to keep the 3 the same. And then our units are going to be centimeters cubed, or cubic centimeters. Make sure that if you have any questions, you ask them either through Google Classroom or email would be great as well. But now let's go on to the next part, volume of composite solids. So we have 2 different things that we need to keep in mind here. Composite solids, if you recall, this is when we have 2 or more solids combined together. So the first thing we want to talk about is we want to find the volume of each solid. And then we want to combine those volumes. Now, in some cases, we are going to be adding. For example, in this one here, we have a cone being added on top of a cylinder. But if we had an image or a solid that looked a little bit more closely like this, and we had a cone that was taken out, then we would find the volume of each again, and we would subtract those two. Okay, so make sure that you keep that in mind. But in this case, we're going to be adding them because we have a cone being put on top of a cylinder or next to. So we're going to be adding these two. So first thing we want to talk about is finding the volume of the cylinder. So lesson 1, the volume of a cylinder is pi r squared times h, area of the base times the height. And from this lesson, 1/3 times pi r squared h. So let's talk about just the cylinder here first. That's going to be this part right here. And for the cylinder, we have a radius of 4, that's right here, and a height of 3. So our radius is 4 inches and our height is 3 inches. So if we go ahead and start using these numbers in our formula here, we have pi r squared would be 4 inches squared, and the height is 3 inches. Looking at our formula then, we have pi times 4 squared times 3. So our volume is about 150.8 cubic inches for the cylinder. Looking at our cone now, which would be this part right here, so let's erase the red part now. Again, we still have this radius here, which is still 4, but now we have a height that is 10. So our radius is 4 inches, our height is 10 inches. So using our formula then, we have 1/3 pi, radius is 4 inches squared, and the height is 10 inches. So coming over to our calculator then, we type in 1/3 times pi times 4 squared times 10, which means that we now have a volume of about 167.6 cubic inches. Last step that we need to do is combine these volumes together. So over here, our overall volume for the cylinder was 150.8. Get rid of the calculator now. And then we're going to add in the volume of the cylinder, which was 167.6 cubic inches. So our overall volume then, if we add these numbers together, let's bring our calculator back now. So we have 150.8 plus 167.6. So our overall volume then would be about 318.4 cubic inches. All right, that is going to be the end of lesson 2. If you have any questions, please let me know.